So in the last video, we learned how to graph an equation that was written in slope-intercept form. We graphed the y-intercept to get 1 point, then we used the slope to find the second point. But what do we do if the equation is not in slope-intercept form? How can we graph it? And one of the ways that we can do it is we can take the equation that is not in slope-intercept form and put it in slope-intercept form. The example that we have here is an equation that is written in standard form, 3x plus 2y equals 6. And what we're going to do is rewrite this equation so that it is in slope-intercept form. So to put it in slope-intercept form, that means we need to get the y by itself so that it looks like y equals mx plus b. So our goal is to isolate this y variable. And this is one of the many reasons why we spent so long learning how to solve equations for a specific variable, is so we could do math like this. There are two things we need to do to put this in slope-intercept form. We need to move the 3x from the left side to the right side. We'll use the subtraction property of equality for that. And then we need to move the 2 from the left side to the right side. And since it's 2 times y, we'll use the division property of equality for that. So I'm not going to harp too much on it because we have spent a huge amount of time solving equations. If you still need to practice solving equations, I definitely suggest you go back and rewatch those videos, because I'm not going to spend a lot of time going over the finer points of how to solve it. Hopefully you're familiar with that at this point. I am still going to label my steps. That is part of showing our work, is labeling the properties. So don't forget to do that. Now, negative 3x divided by 2, I am going to write out as a fraction. And the reason I'm going to write it out as a fraction is because I want to have my slope as a rise over run. So negative 3x divided by 2, I'm going to write as negative 3/2 x. And then I'm going to do plus 3. So now it's in slope-intercept form. Now it's ready to be graphed. This value right here, the negative 3/2, that's our m, which is the slope. And this positive 3 here, that's the b, which is our y-intercept. So let's put those 2 points on the graph. So on the y-axis, we put a point at 3. That's our y-intercept. And then a slope of negative 3/2 means our rise over run is going to be negative 3 over 2. So the rise of negative 3 means we're going to go down 3 and over 2. I've mentioned this before, but it's worth saying again. The positive and negative just tell us if we go up or down. A positive slope, we go up and to the right. A negative slope, we go down and to the right, but we're always going to the right. Whenever you're counting rise over run, we're always going to the right. It's just up and to the right for positive, down and to the right for negative. So here we're going to count down 1, 2, 3. And that's our rise of negative 3. And then we'll go over 1, 2. There's our run of 2. And that's our slope. The rise is negative 3, and the run is 2. And now we'll go ahead and get our ruler, and we will connect these dots. And there we go. We can either go all the way across or write arrows, or I just like to do both. All the way across the graph and put arrows. So there's our equation in slope-intercept form, y equals negative 3/2 x plus 3, and then we've got the graph as well.